Tesla bot Gen 3 just learned to make coffee in 84 seconds by watching a YouTube video. Not 84 seconds to brew it, 84 seconds to master the entire skill. While Figure AI's robot needs 10 hours of training for the same task, Optimus watches once and executes perfectly. Tesla's data reveals each $20,000 unit earns $2,000 monthly in factory work, paying for itself in 10 months. After that, pure profit for whoever owns it. But Elon Musk just confirmed something that changes everything. Optimus can build another Optimus. What happens when your workers start cloning themselves? The 84-second learning window isn't just a speed benchmark. It represents a fundamental shift in how machines acquire skills. Figure AI, backed by major tech investors and positioned as Optimus's primary rival, needs their humanoid robot to train for 10 full hours before it can reliably make a single cup of coffee. Cornell University's robotics system requires over 30 minutes of processing time and still only achieves a 50% success rate on new tasks. Optimus Gen 3 watches the same instructional video once and executes the complete task in under 2 minutes with consistent accuracy. What separates these approaches isn't just processing speed. Traditional robotics relies on motion capture technology, where human workers wear sensor suits that map every micro-movement, or teleoperation systems where engineers manually guide robots through each step. Both methods are extraordinarily time-consuming and expensive. Tesla's approach eliminates this entire complexity. Optimus learns by watching an expert perform the task and then replicating it, compressing what takes human apprentices days or weeks into seconds. Tesla's internal testing data reveals the robot now acquires 150 distinct new skills per day. These aren't variations of the same motion. They're genuinely different tasks spanning multiple domains. Morning sessions might focus on kitchen operations. Afternoon training could shift to household maintenance. Evening sessions might cover factory operations. Each skill, once mastered by a single Optimus unit, immediately propagates across Tesla's entire robot network through cloud synchronization. When one robot learns how to fold a shirt, every Optimus unit globally gains that capability instantly. This network learning system creates a compounding knowledge effect that traditional robotics can't match. Instead of each robot being individually trained, Tesla has built a collective intelligence where every robot's experience enriches the entire fleet. It's analogous to how Google Maps improves as more drivers use it. Except instead of traffic patterns, Optimus units are sharing manipulation techniques and problem-solving approaches across millions of scenarios. The advancement everyone overlooks is what happened with the robot's hands. Early Optimus prototypes operated primarily with single-arm functionality: pick up, transport, place down, repeat. Gen 3 now demonstrates coordinated bilateral manipulation, meaning both hands work simultaneously on complementary tasks. This represents one of the hardest problems in robotics, and here's why it matters. Human hands possess 22 degrees of freedom each. While Optimus hasn't achieved full articulation yet, coordinating even simplified two-hand systems requires exponentially more computational power than single-arm operation. The AI must continuously calculate spatial positioning for both arms, prevent collisions, maintain dynamic balance, and ensure smooth motion while processing real-time feedback. Cooking requires one hand stabilizing while the other stirs. Assembly demands one hand securing while the other fastens. The moment Optimus achieved reliable two-handed operation, it transitioned from expensive prototype into genuine worker replacement. Tesla's demonstration footage showing the robot handling a Model X front crossmember tells us where this technology stands now. That component is large, irregularly shaped, and heavy. The robot uses computer vision to identify the part, calculates optimal grip points, adjusts for weight distribution, navigates the factory floor, and precisely positions it onto a cart. Every step relies on autonomous decision-making based on learned behavior patterns, not hard-coded instructions. Now we need to examine the economics, because this is where Tesla's strategy shifts from impressive engineering into something that could fundamentally restructure labor markets. The company has set Optimus's price at $20,000 per unit. Based on productivity analysis from comparable AI deployments, one robot generates approximately $2,000 per month in economic value through direct labor replacement or productivity enhancements. The mathematics are straightforward but profound. A $20,000 initial investment divided by $2,000 monthly returns means the robot pays for itself in 10 months. Everything after that represents pure profit. Across a conservative 10-year lifespan, one Optimus generates $240,000 in total value from a $20,000 expenditure. That's a 12-fold return. But here's where self-replication transforms this into an exponential economic force. Tesla has confirmed Optimus units can perform assembly operations in their own factories. Elon Musk has explicitly stated the company is developing infrastructure to enable Optimus robots to build other Optimus robots autonomously. Walk through what this means. One Optimus costs $20,000 and generates $2,000 monthly. After 10 months, it pays for itself. By month 11, it has earned enough to finance a second unit. Now you own two robots producing $4,000 monthly combined. At month 16, you build robots 3 and 4. By month 20, your fleet has expanded to 8 units, generating $16,000 monthly. This is compound interest applied to physical labor capacity. Musk has projected global demand could reach 8 billion units. Even at 10% market penetration, that's 800 million Optimus robots worldwide. At $2,000 monthly output per unit, that represents $1.6 trillion in monthly productive capacity generated by machines that manufacture additional machines without human intervention. Tesla's Cortex-2 data center at Giga, Texas, provides critical context. The facility is rated for 200 megawatts of continuous power consumption. A typical large data center runs on 20 to 30 megawatts. Cortex-2 is nearly 10 times larger, purpose-built exclusively for training Optimus. The scale reveals why humanoid robots require different infrastructure than software-only AI. Embodied artificial intelligence generates exponentially more training data. Every movement creates data streams from cameras, tactile sensors, balance systems, and joint feedback. All of this must be processed and fed back into the neural network to refine the robot's understanding of physics and task execution. Tesla runs thousands of simulation hours before deploying new capabilities. Cortex-2 allows them to simulate millions of scenarios in parallel. Optimus operating in every possible kitchen configuration simultaneously. This is how the system learns to generalize rather than memorize. The 200 megawatt capacity isn't for current needs. It's infrastructure for training thousands of units concurrently, each learning from collective experience across the network. This brings us to the scenario that concerns AI safety researchers. If Optimus masters coffee making by watching a YouTube tutorial, what prevents it from learning to pick locks or handle weapons? The robot doesn't understand morality. It understands patterns and task completion. Tesla claims they've implemented AI content filters that screen training videos, blocking dangerous or illegal content. The company restricts learning to verified databases rather than open internet access. The problem is that content filtering has never worked perfectly for any platform. More concerning is propagation speed. When one Optimus learns something, that knowledge synchronizes to every robot instantly. A single compromised unit makes the entire fleet capable of replicating that behavior simultaneously. Tesla's counter-argument focuses on design philosophy. Unlike Boston Dynamics robots that perform backflips, Optimus is engineered for usefulness over spectacle. Training prioritizes mundane tasks, washing vegetables, wiping surfaces, loading dishwashers. And these require sophisticated AI but are inherently low-risk activities. The company deliberately avoids military or security applications to sidestep weaponization concerns. Still, technology history shows this pattern repeatedly. The internet was built for academic research. Social media launched to connect students. Each technology eventually got weaponized or exploited in unintended ways. The crucial difference with Optimus is that it exists in physical space and will operate at massive scale. Software bugs are fixable with updates. Hardware operating autonomously creates irreversible consequences. Elon Musk's claim that Optimus will become the biggest product ever might sound like hyperbole. But examining Tesla's pattern of audacious claims that materialized, reusable rockets, mass-market EVs, neural interfaces, suggests taking this seriously. The core insight is that humanoid robots solve a deployment problem no other automation can address. Our entire civilization is designed around human body proportions. Industrial robots are stronger and faster, but they're fixed installations. Optimus can navigate stairs, open doors, use common tools, and operate in spaces built for people. This enables universal deployment without infrastructure modification. Tesla's emphasis on mastering household tasks is strategically sophisticated. Home environments are chaotic and unpredictable. If Optimus can reliably cook and clean in unstructured homes, it can handle virtually any light industrial application. The company is also leveraging existing advantages: battery manufacturing, motor design, autonomous navigation from full self-driving development. Optimus isn't a new product category. It's the integration of technologies Tesla has already mastered. The economic disruption becomes clear when modeling deployment at scale. If Tesla deploys Optimus across restaurants, warehouses, hospitals, and factories, businesses could see 20 to 30% cost reductions. That's not incremental improvement. That's fundamental restructuring, forcing industries to adopt or become uncompetitive. When robots work continuously while training themselves through videos, the competitive advantage becomes insurmountable. Tesla has faced legitimate criticism about overstating autonomy. Gen 2.5 units were partially teleoperated during demonstrations. The incident, where an Optimus fell during a live event, revealed gaps between marketing and technical reality. Tesla's response provides context. Teleoperation is standard in robotics development for collecting training data. Gen 3 is architecturally designed for full autonomy in real-world conditions. This distinction defines what Optimus represents. A teleoperated robot is an expensive remote control device. An autonomous robot that learns independently is a genuine economic actor, capable of replacing human labor. Based on Tesla's infrastructure investments and engineering hiring, they're clearly building toward autonomous operation. But this creates a legal problem society hasn't addressed. If Optimus learns from videos, who bears responsibility when it copies harmful behavior? If it replicates an unsafe practice that causes injury, is liability with the video creator, Tesla, the owner, or the robot itself? These aren't abstract questions. They're practical challenges that will define how humanoid robots integrate into society. The concerning element is that Tesla is moving faster than regulators can respond. When deployment scales exponentially through self-replication, we may not have time to establish appropriate guardrails before the technology reaches critical mass. So what happens when your workers start cloning themselves? Here's the reality. Tesla isn't just building a robot. They're building the foundation for exponential labor that pays for itself in 10 months and then prints money for the next decade. When one Optimus can build another Optimus, the economic rules we've lived by for centuries stop applying. This is exactly why Musk calls it the biggest product ever. It's not hype, it's math. The moment self-replication goes live, whoever owns these robots owns a workforce that grows without hiring, works without sleeping, and improves without training costs. That's not automation, that's economic transformation. And here's what keeps me up at night. Tesla ships Gen 3 in 2026. That gives us maybe 18 months before the first self-built Optimus rolls off a production line staffed entirely by robots. The question isn't if this happens, it's whether we're ready for what comes after. I want to hear from you. Would you buy a $20,000 robot that earns $2,000 monthly and builds another copy of itself every year? What's the first job you'd give it? Drop your answer in the comments below. If this breakdown gave you a new perspective on where Tesla's really headed, hit that like button. Subscribe to Tesla Zone for the deep analysis you won't find anywhere else, and turn on notifications because the next breakthrough is already happening at Giga Texas. This is Tesla Zone. The age of exponential labor just started, and it's moving faster than anyone's ready for.